We know when a body is moving with a constant acceleration, then the motions of the body is said to be uniformly accelerated motion. So here we shall talk about the equations of uniformly accelerated motion using a graphical method. So let us consider that this body is moving in a straight line path along x-axis with a uniform acceleration a. What is the acceleration? A. Now suppose at a time t equals 0, the positions of the body is x0 and the velocity it is v0 at this point. And after a time t is equals to t, say the position is x and the velocity is v. Alright. Now, if you plot these situations in a graph, then you'll get a graph like this type. Taking time along x-axis and velocity along y-axis. Then at a time t equals 0, what is the velocity? The velocity is v0. Okay, so from this velocity v0, from this point, now the body starts moving with, a uniformly increasing velocity. So the velocity is increasing uniformly till it reaches the final velocity v. Okay, so the velocity here is how much? It is equals to v. Alright. Now, if I drop a perpendicular from this v on the x-axis, then I get this area here. Now this area represents the displacement. Okay, because we know displacement is equals to velocity into time. So that is why this area stands for the displacement, because this is velocity and this is time. So that is the area. Okay. Now from okay, this is a time t equals 0, and at this point how much is the time? The time is small t. Okay. Alright. So let us discuss about the first equation of motion. Displacement is equals to this area here. So I'll name this, this is point A, this is point B, this is point C. Okay, so this displacement in this case is equals to area of the curve AOBC. Now how much is the displacement? Displacement is the final position minus initial position, that is x minus x0, is equals to, what is the area of this region? AOBC. Now this area can be divided into two. Okay, one is this area, another is this area. So this is a rectangle. So I'll write area of a rectangle OADB, plus this area is area of a triangle, that is ADC. Again, if the displacement x minus x0 is, let's say, is equals to s. How much is this displacement from here to here? Let's say it is equals to s. So now s is equals to area of the rectangle. Now area of this rectangle is length into breadth. Length is OB, breadth is BD. Plus area of a triangle is half into base. Base is AD. Height is DC. Again, S is equals to OB. OB is how much? OB is equals to T times BD. BD is the same as OA, and OA is how much? It is the initial velocity V0, plus half AD. AD is the same as OB, so it is equals to T. And this DC here is equals to, from here till here, because the velocity at this point C is V. So when I say BC, it means when I say CD, it means uh, BC minus BD. So BC it is V and BD is V naught. So V minus V naught stands for DC. Okay. So I'll write V minus V naught. Next, the displacement S is equals to V naught T. If you remove the bracket, you'll get half Vt minus half V naught T. Next, displacement S is equals to half Vt. If you combine this V naught T with minus half V naught T, you'll get plus half V naught T. Now taking common half and T, you'll get V minus V naught and then T outside. Okay. After this, we know the average velocity of a moving body is denoted by V bar, and this is equals to displacement into time. Sorry, displacement upon time. Or V bar is equals to, how much is the displacement? Half V minus V naught into T. Upon time mean divide by T. So this T up, T down cancel, you'll get V bar is equals to half V minus V naught. Sorry, this is not minus, this is plus. Okay, so this is the first equations of motion that tells you the average velocity. Okay, next we will look at the second equations of motion. So we know that the acceleration in this case is equals to final velocity minus initial velocity upon the change in time, or A is equals to V minus V naught upon T, or AT is equals to V minus V naught, or I can say V is equals to V naught plus AT. So this is the second equations of motion. Okay. Next, let us look at the third equation. So we know this average velocity is equals to displacement upon time. Displacement is how much? It is S. Time is how much? It is T. Okay. So if you find out S from here, then you'll get V bar into T. Okay. Or S is equals to, how much is V bar? It is half V plus V naught into T. Or I can say this S is equals to half. Instead of V, from equation 2, I can say V naught plus AT. That is the value of V, and then plus V naught, and then T outside. Or S is equals to, now looking in the bracket, you'll get, we have V naught plus V naught, it means twice V naught, and then plus AT, and outside we have small t. Next, S is equals to, now if you remove this bracket, you multiply with this factor half, then this with this cancel, you'll get just V naught, and then with T plus half, this is A, and then TT will becomes T square. Okay, so this is the next equations of motion, that is equation 3. Alright, and the last equations of motion can be obtained in this way. We know from this equation number 2, if you find out T, you'll get V minus V naught upon A. Alright. Also, the displacement S. Okay. S is equals to half V plus V naught T. Okay. S is equals to how much? Half V plus V naught into T. So with these two information, I can say S is equals to half V plus V naught. Now instead of T, I'll write V minus V naught upon A. Or S is equals to, applying formula, V plus A plus B, A minus B, you'll get V square minus V naught square upon 2A. Or 2AS is equals to V square minus V naught square. So this is the fourth equations of motion. Okay, so these are the equations of a uniformly accelerated motion using a graphical method. So I hope this topic is clear, and if you have any doubt, then you can send me or you can comment in the comment box of my video. Thank you very much.